Hi, this is Joshua coming to you again from here in Abbotsford, British Columbia. And I just drew this up real quick. This is one of the demonstrations that I would like to try once I get up to Edmonton. Anyway, you have your Joepipe. This is a steel pipe, roughly 1.5 inches, 1.25 inches by 16 inches. And I have a T, an iron T on there with the air coming in and with the propane coming in here. And you have your swirl device. So it's a very basic Joepipe, but it is modified to convert it into a thermocouple. So in this modification, I have 1/4 inch tubes, maybe a little bigger, whatever I can do to drill and top a hole in here and bring the point of the copper extended out at least 1/4 inch, maybe 3/8 of an inch. So I can actually make a bank of whatever the pipe will allow, maybe a bank of 6 or 7 here, and have it 3 ways around, spaced at 120 degrees, so it actually, when you look at it from the end of it, you have your pipe, you have one here, and one here. Okay, so you got your copper pipes in here, and I probably put a piece of copper in the end so to stop the heat from going up. So you know that your temperature here of the Joepipe is about 2200 degrees inside, and the copper is going to reach near melting point probably around 1800 degrees. Here I have the hot point about 1500. I just dropped it a little bit, but it could be at least 1800 degrees. And if these are long enough, maybe they might cool to maybe around 500 degrees here. So I'm just using for my reference point, I'm using my hot point as 1500 degrees and my reference point here around 500. So this is the reference point on the copper, not the iron. So we know that we have a potential difference in this particular diagram of 1000 degrees difference. And if it doesn't work out for a 4-inch piece, so I'll try a 6-inch piece, because the right at the junction where both the copper and the iron is heated, there is no current, but as the copper cools, it does develop a positive electron flow. Okay, so we got these set up, and as the for the iron, we know that the iron's heating up, like the whole iron actually becomes a junction, a common junction. I don't know whether it's going to work or not. I need to try it. But I'm going to, on the back side of the of the swirl device, it temperature drops off significantly, maybe just above room temperature. So here's the hot point here, and a few inches back, which will drop right down to 70 degrees. So we know that our reference point for our iron is going to be around 70 degrees. And so when you bank all these together, say if each one of these produce a 0.4 millivolt, and you add them together, in this bank of 7 you would get 2.8 volts. And if you had 6 banks, I was going to make 6 banks on this, it actually worked out to 2.8 volts times 6, or 16.8 volts. I'm over my 12 volt DC voltage that I wanted to produce. So if we hook up a thermocouple to this bank here and the other side to the block to the common, we should get a reading of 2.8 volts. It could be less, could be more, and it's going to be interesting to see. And also try variations in the pipe to see which is going to work to be the best. I might have to go about 6 or 7 inches on these copper leads, and to try to drop the temperature right down. But it is going to be interesting, and I don't believe anyone's actually tried this. As far as the Joepipe, your level 3 flame is right here, and it produces a fairly even temperature going around. So you know that the ends of your copper are going to be maxed out way past the oxidation point. I think the oxidation point of copper is around 700 degrees, and and the oxidation point of iron is around 1500, so you're already past those points. So we know that that the junctions are going to heat up and form an oxide, which may elevate or give a greater yield between your positive and negative. I think that's about it. Maybe in the next couple of weeks I'll be able to do this test and have the proper meter. Just going to have to get a meter that's going to read above 2 volts, because I'm blowing my last meter. And but if this works, if this positive bank works with a common junction, then we might be off to the races. If not, I might have to alter, make a bank of iron pipes coming out and copper pipes. Then if this is a bank of iron pipes, this would become your reference point for your iron, and this would become your reference point for your copper. Okay, this is going to be very interesting to see how this all pans out. You never know. Inducing the charge into the pipe, I think that's what actually caused the plasma shift in the past, in variations that I saw. But here I'm trying to produce power as well as heat. So we're going to stop it here, and we'll come back at another time.